All right, we're talking about amides, but I first want to go over what's going on next week. So on Monday, from 4 to 6 are presentations. So half of you, there's 10 of you that are signed up for that. So hopefully you know who you are. Maybe I should send an email. So Angelina, Bianca, Vincent, Philip, Monica, Isabella, Christy, Emma, Melanie, and Jessica. So we're going to do it from 4 to 6. And then I'm going to do class at 6:30, just in case our presentations go longer or we just need a break. And so we are going to have class at 6:30. I'm going to go through study set. What study set did we just have? 10. So study set 11, which is amines. And then from 7 to 8, I will do a review for our celebration. All right, so that's Monday. What day is Monday? The 8th. So if you're not presenting Monday, I do recommend coming. Just come to class like at 6:30. And I will stay after to answer questions. If you do come earlier, if you come like at 6:10, because you want to go over your worksheet or something, if I'm not letting you in, it probably just means we're still in presentations. Yeah, we should be. Last time we were done in 2 hours, but just don't feel like I'm ignoring you. Just wait patiently in the waiting room. And so I just don't want, I just want to make sure we have a break. And also people are presenting. Sometimes people just need to take a break. So it will be a long 4 hours. You'll get to see my day today is 12 hours. So I have 3 classes today that are like this. On Wednesday, just write backwards. So, and Wednesday is the 10th. That's the other of you presenting. So Kaylee, Kristen, Caitlin, so all the Ks. Then Jeremy, Ezra, Sammy, Haley, Allie, and Tiara. I have you guys coming on Wednesday. If somebody from Monday, if something happens, you have to come Wednesday, just send me an email. And so we're going to do the presentations at 6 o'clock. So from 6 to 8 are the presentations. We do have a study set due that day, which would be our last one, which is over what we're doing today. Now, the good news about this is when we do the review, the stuff we're going over today, we'll run into it a little bit more in the review, and there's a review at the end today, which should give us a little bit more practice. I don't want to do it at 8 o'clock at night because I'm usually pretty tired by then. So I was figuring I could do it at 5 or 5:30. Does anybody have a preference? I can let you know on Monday. We'll say at 5. So from 5 to 6, I will go over the study set, and if you have questions on your worksheet and stuff, and if you're doing a presentation, you guys have all shared your screen, so we know how to do that. So we'll be good. The other thing I needed to make a quick comment about is, well, I guess 2 other things. So then the next Monday, so that would be the 15th, is our final celebration. I'll talk about that on this Monday. I did not change the schedule with that because there were a couple people who had already asked and made plans. So I didn't want to add another day to the class, and I think we're fine. So that will be 2 weeks, less than 2 weeks. There is one more lab, but I'm not posting it for this weekend because you guys have your presentations. The papers are due. That's what I wanted to say. The papers are due. So what is today? The 3rd? The 13th. You can definitely turn them in sooner than that, but your papers are due by not this Saturday, the next Saturday. There's nothing due this Saturday. Use this weekend to do your presentation, to get your research done. All my classes are doing presentations next week, and 2 people this morning switched their presentation. They had picked their topics 2 months ago, and so it is never too late to switch. It would be too late after your presentation to switch, I suppose, but if Sunday you start doing research Sunday and you're like, you know what, I really want to do this molecule, send me an email and say, hey, can I switch to this? And I will see the email and probably say, yep, that sounds good. I do want to remind you, we talked about this, that you have to have 2 studies in your paper, and you need to talk about at least one of the studies in your presentation. And so find a study that you can understand and talk about. So using big sciencey words doesn't make it a better presentation, but there's some really cool studies out there, and sometimes that can have influence. And you can always talk to me about it. Send me an email. So there's nothing due this Saturday to use the time, but there is one more lab. And I will post it. It's one we used to make esters in the lab. So there will be a lab, but it will be due next Saturday. So whatever the lab is due will be on the 13th. So I will post it. So if you want to just do it and be done with it this next week, it's got a lot of esters and identifying functional groups and stuff. So it will be good practice for the final celebration. So that's why there is no lab in the folder this week, because this weekend I wanted you to have the time to work. You can turn your papers in absolutely early. That's wonderful. Nobody does, but maybe somebody will. Is there any questions about that? Any of this stuff? I should probably send an email with this information, but just kind of so you have a prelude of what's going on. All right, so let's talk about amides. And I did not reprint my notes. I'm pretty sure I didn't change anything, but again, Melanie kindly pointed out when I think that was on the study set. I'm assuming on that study set, I did not have anything that was different from yours, but just please let me know. All right. So we're doing amides, and the key with this is they're going to have a nitrogen. So it comes from the word amine. I don't know which word came first, and I don't know who named them, but we want to find the piece right before amide, which is propane. So we're going to do 3 carbons. And so these look a lot like the esters. So it's actually pretty fortuitous that we just did that homework set, so you guys have an idea. So this is my 3 carbons, 1, 2, 3. This is my longest chain. That carbon with the double bonded oxygen is going to be your carbon number 1. The thing that is different, so that's the propanamide, is that there's going to be a nitrogen. And that nitrogen is always attached to the double bonded oxygen. The N-isobutyl means attached to the nitrogen is an isobutyl. So we would have that. There is something wrong with my picture. So does Amy know what's wrong with my picture? Wow, you guys are all having issues with the internet tonight. Everybody's getting kicked off.
Are you
missing? Go ahead, Emma.
Are you missing a carbon on the isobutyl side?
No. That's isobutyl. And the N means, when you see that letter N, it means it's attached to the end. And so that's an isobutyl. But I am missing something. She is right on that. Nitrogen makes how many bonds? And they all said, you can all hold up 3 fingers. I'll see that. It makes 3 bonds. So there needs to be a 3rd bond. So we always draw the hydrogen. You actually have to write the letter H in. So same with oxygens. When there is a hydrogen on an oxygen or nitrogen, you have to actually show it even with the zigzags. So that's what this looks like. So yeah, let me give you, I'm going to pause, give you a couple minutes. You can try these and then we'll go through them. It's nice to hear that because it means we're starting to go slowly back to normal. All right. So the butane, we'll do this one. We'll go with orange. Amide, sorry. So our carbon double bonded oxygen, and so we have 1, 2, 3, 4 carbons. And then this is going to hook up to our nitrogen. So that's what it means to be an amide. And then we have to see what else we have. So the N-ethyl, that N, if something's on the nitrogen, it will, these have no common way to name amides. They're always named by this IUPAC thing. So we put an ethyl on there. And then this piece here that says 3-methyl, if there's a number, it means it's on the carbon on the side that had numbers. So there's our 3-methyl, is that piece there. So similar to like the esters, that carbon double bonded oxygen gets the number 1, and then you count from there. You cannot count across the nitrogen. You cannot count across an oxygen. And they are always a little bit confusing because we suddenly have 2 things there, like 2 oxygens or an oxygen and a nitrogen. And then we do have to add another hydrogen on our nitrogen. All right, the next one, benzamide. We're going to make our benzene ring. Remember to put your ring in it. And you have to have a carbon that has the double bonded oxygen. And then we can go to our nitrogen. And so N-isopropyl means that we're going to have an isopropyl on our nitrogen. So this is something, the N is not always going to be the first side group. It is alphabetical. So here the N went first because the ethyl comes before methyl. Here the N-isopropyl went second because of this P. The P stands for para. So that means it's at the number 4. So there's my para-ethyl. And what am I missing?
Hydrogen on the end.
Yes. And they all said in unison, the nitrogen on the hydrogen. Is that Jeremy was our first one there? So good. So maybe you all remember nitrogen makes 3 bonds. All right, so let's try naming. Carbon with the double bonded oxygen gets the number 1, and it's not that you're always going to name, unfortunately on these, it's always going to the left because that's the standard way usually, but it's that you can't cross the nitrogen or an oxygen. So we're going to have 1, 2, 3. So this is just propane and then amide. That's it. All right, on this one, it's just 2. And then these are side groups. So we'd have an NN dimethyl. And then you can either say ethane amide, or you can say, if you prefer, for 2 carbons, you can say acetamide. So that's a preference. I usually see about half of the students go with the ethanamide and half of you like this name better. All right, and then this is benz, and then just amide. That's it. That's all there is to that name. So questions? All right, so I have a question for you. What about boiling point? So compared, where are they going to rank in our ranking? Well, the big thing with their properties is they're going to H bond. If you have an NH, that NH has that ability to have that attraction. And so they're going to be in with the H bond ones. They tend to be pretty large. You can see that. And so the solubility is the smaller ones. So we look at our carbon number. Yeah, so like the propanamide is probably water soluble because it's only 3 carbons. We have an oxygen and a nitrogen. But as we get to larger ones, they just start getting like these guys up here. They got so much going on. They're probably not water soluble. All right, the key property is, we'll get the purple, wearing purple tonight for a reason, is amides are neutral, meaning to pH. Not in their opinion or anything, but pH is neutral. pH is 7. The reason that was important is we're going to be making them from an acid and a base. So from a carboxylic acid and an amine. So amines, just to remind you, in parentheses, amines were bases, but amides, and they were smelly, so they smelled awful. Amides are before the fish has broken down, and so amides have no smell really. And this is something I was thinking about today. This is a really good question. They're really not going to have any reaction. They do have a reaction, but there's no descriptive reaction. You can't check for pH. You can't check for smell. There's really nothing you can do. They're going to be really a last tube standing when we do that test. So this was my question for you. There were actually 2 other last tube standings. Does anybody remember what they were? Amines or not? Amines you can check for base if they're bases, and then you can smell them because they're going to smell like rotten fish. Does anybody remember what the other 2 last tube standings were?
Ether.
Ether is one. What's the other one?
And ester.
No, esters have that ferric hydroxamate test. The other one is the ketones. They were the ones that were the mud. They didn't really react. So ketones, you're not going to get a question where I'm going to ask you to differentiate an amide and ether, because ether you could smell. It would be this really fruity smell that would knock you out. But the ethers, yeah. All right. Amides, their claim to fame is that they are peptides. And so the words came from each other. That's why it's called a peptide, because it rhymes with the amide, right? Dr. Seuss. And that is going to be when we do our reactions on the next page. All right. Look at that. I have all this space down here. I don't know why. That's probably why I have my picture here. And to remind you, yeah, when we do the next page, actually we can do it here because I have the space. An amino acid is going to have, a carbon with, this carbon has 4 bonds around it. It's going to have a hydrogen. It's going to have, this is the acid part, and it's going to have an amino end. And then this is the R group. So this is an amino acid. The R group is variable. And so sometimes it's a methyl, sometimes it's isobutyl, it's different. There's 20 basic ones, 20 that are the building blocks of our proteins, but there's many more. And then what would happen is if we had a second amino acid, we can put it really close. This is the reactions we're going to do on the next page. So amino acids, so again, that R group would be something. They could be the same or different. You have a carbon in between a hydrogen and this. But you can see where we're going with the reactions we just did. You lasso the water molecule. So we find the water molecule, and this is where I have the great grace of the pens that Kristen got me, that if you're able to erase, this will now hook up, and that's our peptide bond. And so Jeremy may be having flashbacks to last term. In Chem 106, we'll be drawing these because we spend like 2 weeks, almost 3 weeks on proteins and stuff. And then there would still be, this nitrogen would still have a hydrogen on it. And so that's a peptide bond is between two amino acids. And so this is an amide. And that's, I don't know which word came first, but they both end with the "ide" for a reason. And that's probably the most famous of all the amides. Sorry, I've been having issues with finding a chair. All right. So we're going to do the reactions. So carboxylic acid plus an amine, you're going to get an amide plus water. If you like the plus water, you don't have to show the water. It's the same question Isabella asked me during office hours. I have a note here. You do need an enzyme. This is not as simple reaction as the ester one, apparently. And so the catalyst in our body, there's always a catalyst that either breaks bonds or puts them together. And so let's go ahead and draw them. Benzoic acid is got that extra carbon before the acid. So there's our benzoic acid. And then methylamine, you just want the nitrogen drawn next to the OH, and then the methyl on the other side. I actually recommend splitting your hydrogens like that. You don't have to, but there's your water molecule that's going to come off. So there will be one hydrogen left. So I'm going to pause again. You guys can try and draw the product, and then you can try and draw this. Down here with the reactions, you're going to cut them into two pieces. And so these, you're cut again next to the carbon double bonded oxygen between that and the nitrogen. So you're here going to put them together, and down here you're going to cut them apart. And then I'll go over what happens in an acidic and a basic condition. So I'm going to pause us, and you can take a break. Apparently I'm trying to pull us. Yes, that was nice. All right, so if you're back, let's go ahead and do this. So your lasso, you don't have to lasso, but it does help some students. So drawing, and then this will go to the nitrogen. You don't have to use different colors, but it does help. And the CH3 is there. So the hydrogen you can show up or down, it doesn't matter. So we're going to go ahead and name it. This methyl is on the nitrogen, so we say N-methyl. And it is always a capital N because for nitrogen. And then benzamide. Okay. And then our next one, propanoic acid. So 3 carbons. And the amine has only that one diethyl. So 2 carbon and another 2 carbon group. And there's our water. So the nitrogen has no hydrogen on it once we get to the amide. So it would be NN diethyl because we have to use the formal way. Amines, this is the informal way where you just say diethylamine. But amides, you always have to have the N's and then propane, drop the E and write amide. That's it. It's not too bad, right? All right. So if you have an amide and you add water, you're going to cut it into the carboxylic acid plus the amine. So put the slash there. Here we have 1, 2, 3, 4. So this side is, we'll just keep the parentheses. We're not losing any carbons. We just write it how it was. You can put the double bonded oxygen up or down, and it's going to pick up an OH. So it becomes a carboxylic acid. And then this side, with the nitrogen, we're going to have a hydrogen on the nitrogen, and then it has 2 methyl groups. You can put it in parentheses like that. If you do zigzags, you cannot. But if you write carbons, you can. So this would just be dimethylamine. And these are separate, so we can put a plus. So dimethylamine. And so there's our hydrogen from the water that we added and the OH. And on the other side, we would have 1, 2, 3, 4. This is methyl attached to carbon number 3, so it's 3-methyl butanoic acid. All right, so we get a draw. So the benzamide means we had a benzene. That's going to be the side that becomes a carboxylic acid. And then had a nitrogen, and on the nitrogen we had an isopropyl. We'd put 1 hydrogen, and then we're going to cut it with water. The pen isn't working, so we cut there. And so our acid, this is where being able to erase can be helpful. So we're going to have an OH. It is in an acidic situation, so we want to keep it as an acid, so that's fine. What's going to happen is to our nitrogen, it still has the isopropyl. It has the original hydrogen. It picked up a new hydrogen, and it's going to attract another hydrogen. So it ends up with 3. You can write it as NH3 and then the isopropyl. This now has a positive charge on the nitrogen. And so it would attract the chloride, would be attracted to it. So in the acidic situation, the nitrogen is going to pick up the extra hydrogen, and this would be called isopropyl ammonium chloride. And questions? If you don't like what's going to happen when we're in the presence of an acid or the presence of a base, cut it in half. That's the big point, is that you cut it into 2 pieces and just do them all as if it's just like this first one where we just end up with the carboxylic acid and the amine. But in the presence of an acid, the nitrogen, because it's now an amine, since it's a base, it's going to attract the extra hydrogen and end up as the ammonium chloride. And then in this case, butaneamide, 1, 2, 3, 4. And then we would come down to the nitrogen, and the nitrogen has an ethyl and a hydrogen. So we'll cut it. And this time the NaOH is going to, we're going to attract, the NaOH is the sodium is going to, we're going to pull off the hydrogen and we'll have a sodium. So we'll have sodium butanoate. And that goes back to actually the study set from Monday, that acids in the presence, and actually tonight that when we did an ester in the presence of NaOH, that was the saponification. The nitrogen picks up 2 hydrogens, it has 1 more hydrogen, and the ethyl, so it's just ethylamine. So different ways that you can write it. The hydrogens, you can show them sticking off around like I did here. If you write the hydrogen after the nitrogen, then you have to show the group on the other side. If you want to show the group after the nitrogen, then we write the hydrogens on the other side, on the left side. We typically don't show the hydrogen between the nitrogen and the carbons because it's not there. It's sticking around the nitrogen. So any questions? All right. So it's having gone through the esters and the homework, once you get the hang of it, it's the same thing. We're just putting together or splitting in two. You're not gaining or losing any carbons. So they're simple reactions. And again, esters show up in our body for triglycerides, and amides show up with proteins, amino acids. So this reaction is used a lot in our body. So we're gonna do practice. Do you guys need a couple minutes to try this, or should we just go for it?
We can just go for it. It saves me time erasing.
I like that answer, Christy. That was funny. All right, so butane, and then it's an amide. So just be careful. Yeah, that it's your study sets. The one for Monday is amines, so it's just going to be nitrogen. And then the amides, this is an amide. It has the double bonded oxygen and the nitrogen. This is an amine. So this is an amide. So butane, whoops, 1, 2, 3, 4. And then we'll have the nitrogen. So that's an amide. And then the N-ethyl means we'll put an ethyl on the nitrogen, and 2 means the carbon, 1, 2, 3, 4. So carbons are numbered, nitrogens, with the capital N, and then nitrogen needs a hydrogen because it has to have 3 bonds. And that's it. All right, the next one, it's ammonium chloride. So this is going to be ionic. So let's just start. We'll add the chloride at the end. It's saying the nitrogen's going to have 4 bonds. So on one side, we have a pentyl. One side you have an ethyl, one side you have an isobutyl. So I don't care which side you put what. I'll put the isobutyl here, the ethyl down here, and the pentyl. So 1, 2, 3, 4, 5. So that's carbon 1. This line is just the line to the nitrogen. So 1, 2, 3, 4, 5. And then this, we'd have to write in the hydrogen. So ammonium means there's 4 bonds on the nitrogen. And that gives the nitrogen a plus. And so technically you would have brackets around that, and then the chloride is attracted to that whole molecule. We don't want to put the chloride at the end here because it is not on the carbon. So that's where the brackets are helpful. Yeah, so it has 4 bonds. All right, on this one, here's our nitrogen. So we're going to alphabetize these. This is a propyl, this is a methyl, and that is a sec-butyl. And sec-butyl is alphabetized by the B. So if you remember way back, the first or second week, I would label things like around, and people are like, why are you doing that? Do we have to do that? This is kind of, I guess, why I got in the habit of doing that, is when we get into things like the ethers and the esters and the amines. So sec-butyl goes first alphabetically, and then the methyl, and then the propyl, and then we just say amine. If all the pieces around it are really simple to name, just name it as the common way. Amides, we have to do the IUPAC way, which means we have to start numbering. And that carbon double bonded oxygen gets a 1, 2, 3, 4, 5. This is an old practice because I have lots of carbons. I don't have all the zigzags. I didn't used to teach the zigzags the first day, and then when I taught it in the second week or third week, students freaked out. And so I found if I teach them the first day, you're all comfortable with them. And then you don't like when I draw the carbons. But 1, 2, 3, 4, 5. So this is pentane amide. And then let's get all our side groups. So that's a methyl, and that's an ethyl. Ethyl comes first. So N-ethyl, capital N, and then the methyl is at number 2. So 2-methyl pentane amide. Nobody asked this, but your celebration, it's during finals week, but it's like the other celebrations. So it's going to be over. I mean, there's enough here, the esters, the carboxylic acids, but the amines and the amides. There'll be similar format where you name some stuff, you draw some stuff, you do some reactions. All right. This is an amine, but it's a special amine. And I don't expect anybody to have remembered the name of it. This, when the nitrogen is attached directly to the benzene ring, what I circled in orange, that is aniline or aniline. If we are in this, so sweet aniline, that is it. I'm pretty sure that's the song they were trying to sing. And this piece up here, that's isopropyl. And we want to say aniline is an IUPAC name. You have to do this the formal way. So we have to say it's attached to the N, so N-isopropyl. If it was attached to the carbons, it would get a number. If it's attached to the N, we say N-isopropyl. All right, questions? Everybody's always so quiet, especially on Wednesdays. I think it's the middle of the week. All right, we're going to do reactions. And so we're going to cut. I think it's really helpful to draw the line and cut into your two pieces. Yeah. All right. So 1, 2, 3, 4. So if you want, you can just do 1, 2, 3, 4. Or you can draw all your carbons out, but that's this side. And then my other side is here. So my nitrogen, again, I like to show the hydrogens on the other side of the nitrogen. And then it would have, that's an isopropyl is what this is. So you can write it like that, or you could done the NH2CH32. Either or, it's the same thing. However, then you have to go back and say, hey, it's in the presence of an acid of HCl. So we have to pick up another hydrogen. This becomes a positive, and then Cl negative is attracted to the whole thing. Questions? So this would be, yeah, isopropyl ammonium chloride, if you want a name. So isopropyl ammonium chloride. Technically, all three separate names, actually, because it's a salt. All right. So acetic acid just means 2 carbons. So we're going to have a 2-carbon acid. And ethylamine, just we'll have our amine and an ethyl. And lasso off your water molecule. Draw your carbons, do not change. You do lose the OH and you do lose one of the H's. So there's only this double bonded oxygen. And this is going to attach to the nitrogen. There is still one hydrogen and there's an ethyl. So it's N, let's try again, sorry. N ethyl acetamide or ethanamide would be the name of our product. So we're either going to cut into 2 parts or put it together. That's really the reaction that's happening. We don't have the oxidation reductions anymore. That was the last test. So now we're going to do the distinguishing test. And so they are both amines. So any idea how you would distinguish these two? What is different about these 2 amines? There must be something different. Well, they both have 3 carbons. So trimethyl means 3 carbons. And this is an ethyl plus a methyl, so this is 3 carbons. They're both pretty small. They're both going to be pretty much water soluble. You can always make a probably why I gave you space so you could make a picture. This is nitrogen with a methyl on each side of it. This is a nitrogen with an ethyl and a methyl. And you can write the methyl down that way and put the hydrogen there. So a review from what we did on Monday, see if anybody remembers. These are different categories of amines. Does anybody remember what category amine these would be, each one? They're a different category, and that's how we're going to be able to distinguish them.
Is it has to do with like primary? So is the first one, is that a tertiary because it's connected to
Yes.
3 carbons?
This is a tertiary because there's 3 different, yeah, they can be the same or different, but it has 3 different carbons. And again, I just drew them as a line, which is perfectly fine, but you can always draw it in as a CH3, CH3. And then on this side, they tend to write it that way. And so this one's attached to 2. So what would it be, Melanie?
Be secondary.
Yeah. So how can I distinguish them? It's not an oxidation test, but one of them has something the other one doesn't. Anybody?
Is it more surface area?
There's a better answer. I don't really, surface area isn't going to be that big of a difference. This one has an H bond. If you have a hydrogen on the nitrogen, so primary and secondary amines have an H bond, that is going to make it have a much higher boiling point. So H bonds, again, there's going to be an attraction. The attraction is greater than a nitrogen for another nitrogen. So that NH makes it a very polarized bond as opposed to the nitrogen carbon bonds. And that's going to give it a much higher boiling point. They would both be bases. They would both smell terrible. They both would be water soluble. So that would not distinguish them. But this would have, because of the H bond, it would have a higher boiling point. This is on the practice for a reason, so that we talked about this the other day, but so if we run into it, the next one's a much easier answer. So what's going to be the distinguishing thing for that one? This is ionic. This is an amine. So with that, any thoughts? There's several things you can do here. So the amine is, go ahead.
Boiling point, because ionic has the highest boiling point.
You could do highest boiling point would be ionic. Actually, even simpler is, well, this guy's probably, the other test you can do is pH, that the amine is going to be basic. So pH or litmus blue. And this one is now going to be the conjugate acid. So they would have very different pH. Boiling point would work too. There is one other one. So you may know what the other possibility is on this one. It's the one I never recommend, but it is smell, that the amine is going to smell like rotten fish, rotten meat, whatever rotten thing you want to talk about. So old fish. Ionic is no smell. Amides, no smell. So any of those 3, just pick one test. And again, you have to tell me what's going to happen. So the ionic has a higher boiling point, or the amine is going to turn basic. Again, you could not do the basic test or the smell test on the first one because they both were amines. So they both would smell awful. All right, so the last one, this is an amide. We can draw a picture. So you have the carbon double bonded oxygen, or you can just show the bend, and then it goes to a nitrogen. So we have NHs, it's going to H bond, and then aniline, sweet, and that is a benzene, and the nitrogen is attached directly to the benzene. So there's nothing special about either one. They both have NHs, so they both are going to hydrogen bond. The size of them is not that big a difference. I mean, this one does have the double bonded O, but the simplest test, boiling point, is a pain to do. It takes time, like significant time. There's a really easy test here. There's actually two, but pH. This is basic pH. And this is neutral pH. So if you see an amine, just do the litmus paper, carboxylic acid. That if the other one is not going to have a similar pH, you could do smell. The aniline's not going to smell as nice, but the pH would be a better one. That video that I made in the lab, they all start smelling the same after a while. Questions? We got done early. All right, so I want to go back 2 pages, remind you, oh, actually I have a blank page here. So just to review, Monday, presentations are 4 to 6. So this is on the 8th. And then 6:30, we're going to do the study set 11, which is the amines. I'll have an office hour in between there if there is time. And then from 7 to 8, I will do a review, like kind of like we just did, but for the final celebration. On Wednesday, the 10th, our presentations are going to be from 5 to 6. It probably won't go to 6, 5 to 5:30. I'm going to do study set 12, which is amides. And then from 6 to 8 is our presentations. So hopefully you know when you're signed up. If not, just stay on and ask me. And then Monday, the 15th, is our celebration 3, which is our carboxylic acids. Actually, we'll do a review on Monday. So carboxylic acids, esters, amines, and amides. And so it'll be a similar format. It'll be show your work. And we'll talk about that more on Monday. So if there's no questions, I'm going to stop recording and then I'll hang out to go over worksheets. And this time I stop.